Hello, and thanks for joining us today on our Hunting C2 panels with ONYPHE webinar. I'm James Atack, the Deputy CTO here at ONYPHE, and I'll be walking us through some threat investigation scenarios using our new CTI scan category. So let's get started. First of all, a few words of introduction about ONYPHE, if you need them. ONYPHE has been scanning the internet since 2017, one of a handful of companies doing so at that time. We are now a fully bootstrapped company providing big data for cyber defense to leading CSIRT and SOC teams for governments and Global 500 businesses. We're proud of our products in the attack surface management and attack surface discovery space, and our API-based on-demand active scan solution is being used by organizations to enrich their processes with real-time data on internet exposed assets. And we've now added a fourth dimension to our solution portfolio with CTI scan, designed for threat analysts and internet investigation use cases. So what is CTI scan? Well, with CTI scan, we've restructured our data model to better fit CTI use cases. We've added additional data points that analysts like to pivot on, and we've redesigned our scanning infrastructure to allow us to scale up to thousands of ports, and soon tens of thousands of ports. We scan the whole IPv4 space from multiple locations at least every week, and we have 30 days of historical data in this category. The graphic on the right here shows the layered nature of our new data model, inspired of course by the OSI network model. So for example, if you're looking for a data point related to the IP layer, such as the ASN or the IP destination address, you'll find it in the IP layer. And if you're looking for a data point in a TLS certificate, then the cert layer is where you'll find that information. Let's move from theory to practice and take a look at a concrete example of how CTI scan can be used. CTI Academy recently updated this 2024 blog post on hunting C2 panels, where they provide examples for finding known C2 panels using internet search engines. Looking first of all at the Mythic C2 panel, they list a number of different pivots that can be used to identify hosts running that software. So let's first look at the issuer organization field on the TLS certificate. I can query CTI scan by constructing an OQL request using this layered approach. OQL, for those of you who don't know, is ONYPHE query language. It's the language we use to query the ONYPHE platform, and for this demo I'm using the new version OQL v2. So I'm going to use this query, category CTI scan, and I'm using the cert layer and the issuer organization field with the value Mythic. So a result is displayed for each host port combination matching the filter. A quick word about some of these results. So when there are two flags like this, then the first flag relates to the physical geolocation of the IP address, and the second to the logical address. That's the real world address associated with the subnet in the whois. So we can see with this server, it's hosted in the United Kingdom, but the IP subnet belongs to a company based in France, and indeed we can see that's the case here with OVH. When there is a fav icon, that is also displayed here next to the result information. Let's try another example using the HTTP and HTML layers. When we're using multiple filters in OQL, there's an implicit Boolean AND between each element. So I'm now going to search for HTML title text Mythic and HTTP header content length 585. So here we have 767 documents that match Mythic. We could examine specific data points we might wish to pivot on, could look at different tabs of information here, or we can view the whole JSON document on the JSON tab, which is great for getting an overview of the data that's available and for seeing which filters you could use. Before to move on to our next C2 panel, we're just going to take a look at favicons. As you might have seen on the diagram describing the CTI data model, we've decided to give commonly used analytical pivots their own layers. So you'll see that for GA3S in the future, for GA4T, favicons, hash, and others that are already available. Therefore, if you want to search for a specific hash of a favicon, like this value here, then you use the favicon layer directly. So that looks like this. Favicon data SHA-256. And the calculation of this value is compatible with other threat intelligence sources. So if you're sharing this as an IOC, then people using other platforms can benefit from that. And so this here is giving us all of the results with that exact favicon. The next panel we'll hunt for is Supershell. As with Mythic, Supershell is identified by our platform, so we can query directly for the component using our component layer here. And with OQL, if we want to have an or Boolean condition, then we put question marks before the filters. So with this query here, I'm searching for either component product Supershell or component vendor Supershell. In this case, the two strings are identical. And so we have 836 Supershell results. If we look at the data model, you can see that this field here has a text suffix. Any field in the CTI scan data model that has a text suffix is a full text search field, allowing for simple search using keywords. So this app data text filter allows for full text search on the service responses. And the data tab also shows that service response. To illustrate this, on these Supershell pages, there's an interesting text string here using Unicode characters. So we can search for this using app data text. And so here we're doing a full text search using this string. And we can see we collected a few more results there. If we wanted to see what those extra results are, then we can exclude our known Supershell machines using a Boolean not condition, and so we add an exclamation mark for that. And so here we have 22 results where we can see that the underlying product is still Supershell, but the system owner has modified the default HTML title or other parts of the software. So we could add this string into our product detections following the webinar. Just to confirm that, we could, on the analytics tab, you have all of these different pivots. We could use this HTTP body data SHA-256 value. And if we search for that, we can see we have 3 results all for the same IP address. And most of all, we can see that that's a different value. It doesn't start 6084. So we're really dealing with a unique system, but we were able to find it thanks to this full text search using a Unicode text string. Let's go back to the data model, and we'll go back to the search for other Supershell systems. This is good. So if we look at the data model, we can see that some fields, such as this entity one here, have suffixes for both raw and text. That's the case for HTML title, for example. This gives us the flexibility to choose between full text search operations and other search types such as regular expressions and wildcards. So, for example, using HTML title raw, we can build a regular expression to search for other web pages with the same pattern of an ASCII string followed by these two Chinese characters. So that looks like this. So we have a regex function. We specify HTML title raw as the field we'd like to search, and then in the quotes we have our regular expression. And here I'm excluding these known Supershell results. And so here's the results for this query. And indeed, we can see that the HTML title matches our regular expression. It's not really surprising that there are many results because these two characters just mean login in Chinese. We can combine multiple regular expression functions. So if I wanted, I could combine two regex, and this is these combine with an AND Boolean condition. The second one here is just looking for domain, top level domains X, Y, Z, or top on certificates. So there we can filter our first regex result with a second regex result, and we can see that we get the documents we're looking for. These regex functions also exist in not and or variations. So if you needed to have either this function or that function, then you can use or regex. The final C2 panel we're going to look at is Cobalt Strike. In the blog post, the component is only identified either by the platform already or using this TLS certificate, so default TLS certificate. So let's look at both of those options to start with. So I'm going to use that subject distinguished name. So we have 89 results that match this default TLS certificate. In fact, this issue a common name, Major Cobalt Strike, is present in all of these certificates as well. So we could just use that filter because it's much shorter. So we can see what's going on. Let's add the existing ONYPHE platform detection for Cobalt Strikes. So component product Cobalt Strike. And so with this older default TLS certificate and this newer default TLS certificate, we have 911 results for Cobalt Strike. Now, let's say we wanted to investigate a specific malicious infrastructure that's using TCP port 54321. With the CTI scan data model, we use the TCP layer to specify the TCP port, TCP dest 54321. However, if we do this, we don't get the results that we want. We have 1.6 million results here, which correspond to basically all of the results for this port 54321, because these two OR conditions become essentially optional, and we just end up having the results for our AND condition. What we need is for these two Boolean OR conditions to be grouped together, and then we will get the results that we're looking for. And so here we have either this condition or this condition and this condition. And indeed, we can see here we have that Cobalt Strike default certificate put on the port 54321. Another interesting way of investigating systems using Ctiscan is on the Analytics tab. We can see that using the field services ports that some of these systems have port 22 open. So we can, by using services port 22, we can identify systems that expose Cobalt Strike on port 54321, but also have an SSH port open. So that could be helpful when you're narrowing down systems in your investigation. We could now pivot on these IP addresses and look at them more closely, but instead we're going to look for other ways of identifying Cobalt Strike servers. As there were only these two pivots in the first article, I found this second post which describes 10 different ways to find Cobalt Strike servers. One of the points made in that article is that the C2 server's default response is a 404 message with content type text plain and a content length of 0. So using Ctiscan, we can search for those responses using a combination of this HTTP header hash and HTTP content length 0. So let's do that. And so here we can see this characteristic header that's described in the blog post where you have a 404 response, the header is very short, content type is text plain, and the content length is 0. We have to specify the HTTP header content length as a specific filter because the body content length is excluded in the calculation of the header hash. That's a standard across platforms like ONYPHE. Interestingly, we can see in these 3,681 results that some of them are already identified as Cobalt Strike and some of them aren't. So we have some new results here. If we look at this machine, we can see there's very little to investigate. Everything else interesting in the past that we found on Cobalt Strike has been on the TLS certificate. So let's ask for results where TLS is enabled. So app TLS true will give us that. And let's also exclude the known Cobalt Strike certificates, the default certificates we were looking at before. So we're only looking at new or unknown systems. So here we have 922 results. If we glance down the list, we can straight away see some interesting fields here. This system has all of these Cobalt Strike characteristics, but it's also presenting a certificate for starmicrosoft.com. And this is the case for many of the others. So what we might want to do here is examine specific fields across this data set of 922 results. And we can do that using our APIs and our ONYPHE client tool. So what I'm going to do is pass this same query, I'm just going to copy it into my clipboard. I'm going to pass this same query to our CLI tool. So our CLI tool takes a search parameter, and I can just paste in what we were just working on. And this will return JSON documents, so I can pipe it to JQ, and we have exactly the same content as we were looking at in the JSON tab on the web page. So this is One of the nice features of this CLI tool, though, is that we can actually process this JSON output directly within the tool. So if I want to know what common name or subject alternative names are present on the TLS certificates on these hosts, then what I can do is just filter these results for the list of values of subject common name. So I could do that, for example, just by adding a pipe, unique, cert, subject, CN. And then I close the query. So I add this to the OQL query, but it's actually executed in the ONYPHE client. And here we are, we have a list of all of those subject common names from the TLS certificates. Just glancing up the list, we can see values. We don't know if these are properly malicious, but in any case, they're designed to blend in with regular traffic. More Windows updates, Amazon.com as well, and Bing here. So to finish, I'm going to export the list of IPs that have both Cobalt Strike characteristics and a Microsoft related TLS certificate. So to do that, we're going to use everything that we've looked at in one query, and this is it. So here I'm combining the header hash for that 404 response with the content type text plain, the HTTP header content length 0. I'm excluding the default TLS certificates for Cobalt Strike, but I'm asking for results where TLS is enabled. And then I have a group of 3 OR functions, OR wildcard for cert subject common name, an OR wildcard for cert subject alternative names, and an OR regexp for this keyword Bing surrounded by any characters in a regex. And out of the resulting data, I want to select unique IPs with the country and the ASN. I'm actually going to add a counter to this query so we can see how many results we've got. So this is the query. With these big wildcard queries and regular expressions, it's not impossible to get a timeout because we're querying 5 billion documents in the Ctiscan category, yeah, it can time out. But in that case, you should always just rerun your query, as there's caching mechanisms on the back end, and there's a good chance you'll get a response the second time. So here we have 21 results. Glancing down, I can see there's 5 different countries, about 10 or so, maybe a dozen different ASNs, and so all of these IP addresses appear to be hosting a Cobalt Strike Team Server C2, and they're presenting TLS certificates that disguise themselves as something belonging to Microsoft. So these could be interesting to hunt in your firewall logs. If you find any of these IPs in your infrastructure logs, then it could be worth investigating. So that's the end of the demo. We've now got 5 minutes, plenty of time to answer any questions you might have. So there's one question which I'll just answer live. We'll share the slides at the end of the call. So we're running this webinar series at the moment for existing customers, and what we will do at the end is share a video of the webinar in English and also in French. So all of this information will be available on our YouTube channel. Are there any other questions? A question about us contact details. So this is our general contact email address. If you're an ONYPHE customer, you can also contact us on our support address. We're more responsive to our support address, but this is our general queries. If you have any questions about what's possible, then please feel free to do that. And if there are no other questions, then we can finish 5 minutes early. Thank you very much for your time and your attention. And I hope we get to talk soon about what's possible using CTI scan. Bye for now.